Welcome to everybody. My name is Alessandro Confetti. I'm a lead technologist at ThoughtWorks Italy. And today I would like to talk not about technologies. I mean, we will talk about technology, we will see code, we will see something. But I want to talk about what you can do for the future of the internet. I will not talk about how to make you more richer with blockchains or other things. So let's go to what's about the decentralized system. And the funny thing is that when you search on the internet for the decentralized system, you find this image. But it's not so often to find out also when and where this image is from. So the original image was from a book of 1964. And the funny thing is that everybody who talks about distributed, decentralized, blah, blah, blah systems use this image. But a lot of things has happened since 1964. And I think that the situation now is a bit more complex than this. And I rather prefer these two images, this one and the next one, which are from a more recent article, which I invite you to read. And so, yes, we have centralized systems. And then we have distributed systems, decentralized and peer-to-peer. But, more importantly, we have to wonder, even in peer-to-peer networks that we think that are the most distributed and decentralized systems, if they really are so. Because nowadays we have peer-to-peer systems and networks that are hybrid or pure. That can be a bit more or less more decentralized. Even for example, Bitcoin is a pure decentralized system. Ethereum is not. We can debate about the fact that it's hybrid or pure with a facilitator, because the Ethereum Foundation can issue a hard fork of the system. So, what's important about this is that the internet started as a very decentralized and distributed system with ARPANET. And let me introduce you to my very own and personal and opinionated history of the internet, just to understand where we are and what we have to do. So the sad things about this timeline is that there is only one technology that was invented before I was born. So the first one is the ARPANET. And that's the only one, sadly. And so we built the very fundamental block of the internet in 1969. And it took almost 10 years to develop TCP/IP and DNS systems. And it was only in 1990 that the World Wide Web revolution started, with the first static browser and static web server built by Tim Berners-Lee. And it took almost 3 years, a huge amount of time nowadays, to have a more dynamic World Wide Web with CGI. I don't know how many of you has used CGI in your life, but okay, that's where it all started. So we had static internet, then we have dynamic internet, and life was easy, almost, but it was not enough. And system became more and more complex. Deploying systems, very big websites became more and more complex. And an incredible thing was born in 2004, AWS. Actually, in 2004, AWS was very, very hidden, but they built the foundation upon which the internet, the services on the internet became elastic. So you don't have to worry about how and where to deploy your web server. Someone else was able to do it for you and also to scale. But that was not enough. And because it was always synchronous. The internet was dynamic, was elastic, but was synchronous. And we needed Node.js and Akka, for example, to inject the asynchronous World Wide Web in the system. So nowadays, everybody talk about asynchronous things, and if you don't build asynchronously, you are out of the game. And in 2014, even the last piece that remained. So where do you compute your request? When do you execute your functions? You had, yes, you had AWS. You could deploy all your websites so whenever you want. But at the end, you also had to manage the computing power in order to execute your request. And with AWS Lambda, we had serverless computing finally in place. So it has been almost 3 years that AWS Lambda is in place. And what we got at the end of this graph is that from a very decentralized and distributed system, we ended up with a newly centralized serverless computing platform. So yes, of course, inside AWS, everything is distributed, is elastic, is dynamic, but it's inside AWS. The same is for Azure, the same is for Google. I don't want to talk about the problem we had with Facebook and Google at the moment, but that's another issue. So the interesting thing is that this is not the only history. Something else also happened. And we have to start with Usenet. Usenet is an incredible system. It started in 1979 and was built and developed in a way that could be run inside disconnected networks. I don't know how many of you have used Usenet, I don't know, or heard about it. It was a sort of distributed mailing list where people could exchange comments or ideas and also files. And nowadays it's still in use, not to distribute very legal thing. But again, the main important thing is that once there was no internet connection between Australia and US, the Usenet archives were stored on tapes and sent from US to Australia to a central server. I don't remember if in Sydney or in another place. And from there, all the network connected to Sydney was updated. So we had from the very beginning a service that was completely distributed and also able to run through disconnected networks. And we forgot about it. Then we had Napster. It lasted only 2 years before it was shut down, but it proved that a global peer-to-peer network was feasible. It was actually not a purely distributed system, because in this way it was more easy to be shut down. But again, it proved that it was possible to have a peer-to-peer network that was worldwide, even with very low bandwidth. Nowadays, we are always complaining about bandwidth, but I can assure you in 1999, the bandwidth was a problem more than today. And in 2009, Bitcoin started. And was incredible Bitcoin had a lot of technologies put cleverly together. So, but from what is interesting for this talk is that it proved also that not only it was possible to build a global distributed peer-to-peer network, but it was also so secure that you could use transaction on this system and build a sort of economy. And then on top of Bitcoin, a lot of services started and died, and who cares? I mean, Namecoin was one of the first attempts to switch to a distributed domain name service system. And then in 2013 and 14, DAT and IPFS were born. And they were aimed at providing the enabling technologies and the software required to build a new kind and more secure and more distributed kind of Napster without the illegal part. And today we will talk about them as well. And finally, in 2015, somebody used the technologies that were inside Bitcoin to build a new kind of thing. Not only a blockchain, not only a distributed ledger, not only a peer-to-peer system, but also a distributed computing platform. Ethereum, aside from the crypto values, is a completely distributed computing platform. And then other things happen, for example, Big Chain DB or other attempt to build also database technologies on top of Bitcoin. So, in this way, we slowly reacquired the possibility to have not only distributed system, but also peer-to-peer computing platforms. Of course, not all these technologies are production ready. And this call is about technologies, but is also a sort of call for action. We need, as developer, to think about every time we develop a service, we develop an application, we develop something, enabling the future of the internet to be free, to be distributed, to be open, or I'm closing it again a bit. Of course, that's an important question also about how you can become rich with the internet, but that's another point. So, if you go on the AWS site, you will find this picture that explains you how, nowadays, from the Amazon point of view, you should build an application. So, no more virtual machine, no more hardware, no more anything. Just Amazon. Amazon is the answer to all your dreams. You have a place where to store files, and almost for free. Not almost. You have a place where to store your APIs. You have a place where to execute your code, and you're happy. Actually, this is an incredible platform. It enables you to build incredible things in a very short time. But unfortunately, it's not open. So, how we can think or rethink the way we can build internet application today in order to enable them to be a bit more decentralized and opened. Before going into this, we have to remember, the first point is to work on S3, the place where we store things. Okay? Is there any other way of storing things? Storing things means storing your HTML pages, your mobile application. This is not S3, of course, it's the place store, but that's the same. So let's start with HTTP. So what is HTTP? When you build a site in 1990, it was very easy. You run your own web server, the lucky one who had internet access at the time, but you run your own web server, and with a client, a Mosaic browser was the first, you could ask for a page and receive a page back. So the HTTP layer is a protocol and a transportation layer in order to move files around. Then, when the traffic increased, we introduced balancers. So one web server was not enough to respond to all the requests. So a smart balancer was in place. Duty was to switch to the less used web server in order to respond faster. But again, the communication was very simple, from a client to a load balancer to just a web server and back to the client. And then, nowadays, again, we added the load balancers, we have zones, we have very clever things to route these simple requests from a client to a server, but at the end, no matter how smart it is, the communication is always one server and back to the client. So, is there a way to change this? Maybe, yes. Let me introduce you IPFS. How many of you knows IPFS or use IPFS? Not so much. So IPFS is a very interesting acronym. It means Interplanetary File System, so it's quite ambitious. Okay? The stars are not just a handy background. That means there is a file system node in each star and so on. So, but the real important thing about IPFS is that it changed the way you access resources on the internet. Nowadays, you access resources based on URL. So an address, which is a path to the resource. And at the root of the path, there is the server where the resource is stored. With IPFS, this changes. You don't access a path. You access a content. in fact, is called also a content-addressed protocol. So let's see how the things change with IPFS. So IPFS can be accessed through HTTPS, and that's not the best way to access it, but let's see. So again, we have a request for a file. The HTTP gateway talks to the peer-to-peer network, and the peer-to-peer network responds together to the HTTP gateway. So at least the communication between the peer-to-peer network and the gateway is distributed. And why it's distributed? Because each file inside the index HTML file that is stored inside the nodes of IPFS is sliced in several blocks. So when a request is routed through the peer-to-peer network, the network adjusts the response in order to provide, in the fastest way, the response back to the caller. So each one responds with just a piece of the file. The more the peers of the network are available with the file, the more faster you receive it back, and the less bandwidth is required, okay, between the gateway and the network. Because the other thing very important about bandwidth, we all scream about bandwidth. We need high bandwidth. We need more bandwidth nowadays. But the reason because we need more bandwidth is that we use the bandwidth in the worst way. So the way we build the internet so far requires that each node has the maximum bandwidth to the next node in order to be able to download things at a faster rate. But think about developing countries where networks and electricity is, not always available. So how you can cope with these situations? Okay, you need a better protocol. And another important thing is that if the client asks the same file directly, ask the same file directly to the network with the IPFS protocol, then it receives back from each peer a piece of the file. And it's much faster, and it requires less bandwidth between the client and the network. So let's see how it works. In order to install IPFS, it's very simple. It's the implementation is in Go. One of the two implementations is in Go, so you download the tar file and pack it, and you have an executable ready to go. I will show you. Oops. Let me see if I'm able to. Okay, let's do some code. So let's imagine that we have a very complex HTML application. Yeah, just a second. Okay, so we have this incredible complex HTML application, and we want to distribute it through IPFS. So we already have the file. I already installed IPFS, so I don't repeat the installation. Just a second. Okay. Can you see? Okay. So we have a folder with a file inside. Bigger. It's clear? Let's try. Okay, so we have a folder with a file inside. The easiest thing. In order to add to IPFS, we just say add this file to IPFS. And what happens when we issue this command? Two things happen. The first thing is that, okay, IPFS compute an hash of the file. You can see it here. So this is the hash of the file, and this is the new address of the file. And the second thing is that this computed hash is also moved inside a folder, which is inside your home folder, .ips. And from this place, could be distributed to the network. How we can distribute it? Okay, it's not difficult. We need a daemon. I don't know if I'm breaking something. So you need a daemon, okay, that need to be running on the background. Okay, and this daemon says to us that, okay, let me copy in order to avoid stupid things. So the first thing, we can access this file from this URL. Okay, so when the daemon starts, it also starts a local gateway, local HTTP gateway. Okay, so if I go here and paste here, okay, here we are. Okay, so we have the file. That means also another thing, that not only this file is stored inside my computer, but since I started the daemon is connected to the peers of the IPFS network, and so other people can see it. I mean, it's actually stored inside my computer. So if nobody else asks for the file, it remains inside only my computer. But at the moment, there is a public gateway, which is always available, to which I can ask for my file, which is maintained by IPFS. Okay? So if I ask the same file, hoping that the network is functioning. No. Sorry. No, it should be functioning, but it's not. It takes some minutes, perhaps, to connect, or I don't know if we are in a disconnected situation. So I can ask for the same file to another gateway. And the important point is that no matter how many gateway there are, my actual address is not made of the first part of the address, so the name of the gateway, but only the content. Okay? In this way, I can ask for the file from other computers. I can pin the file in order to store it permanently on my computer as well. When you ask a file through a gateway, the files remains inside the cache of the gateway for 24 hours, or at least if there is no space left on the cache as well. Okay, but this is a very simple file. Okay, so let's imagine that we want to build a more complex HTML application made of 2 files. So in this case, we have 2 options. The first option is to add manually each file to IPFS, and each one will have its own hash. The other option is to add the whole folder, and in this case, something very interesting happens. So let's go. If I say, okay, don't add the single file, add the entire folder. Oh, we don't only have 2 hashes, one for each file, but we have a third hash, which is the hash of the folder. Because actually, what IPFS does is to compute a Merkle tree. In a Merkle tree, I don't know how many of you knows about. Fine. So, for the other ones, the important part is that this hash is not only the hash of the folder, but also the hash of the content of the folder. So if you change, no matter how deep the level is, something inside the folder, all the hashes for the surrounding folders changes as well. Okay? So in this way, you ensure that you always point to the right version of the folder. So if you change the folder, the hash changes. Okay? And we also added in this complex application a link. Okay, and that's interesting because if we search for this address in the browser, sorry, I forgot to, let me keep just a second, the daemon up in the second window. Okay. Fine. Okay. If I click on the link, okay, can you see the address bar? Not very well. So the point is that I can access a link inside an IPFS website in two ways, with an absolute content addressed link or with a relative link. So the page, in this case, is a relative link. So you should see at the end /talk.html, okay? That's not the best way of doing things in IPFS. So it's better to have each file as a content address link. Of course, if you have to convert a traditional website, static website, to IPFS, you could encounter some issues. Okay? So, and so on. You can build more and more complex structures, but at the end, what happens is that you build a Merkle tree. So you have, for each point of the tree, a unique hash that the whole network can access, no matter where it's stored. So if I pin this hash on another computer and I shut down my daemon, the page and the website is still alive because someone else is providing the file. So the more people are using your file, the more reliable is the access to your file. So of course this is strange for a website. Can be much more common for other kind of resources. Think about JavaScript libraries, for example. So a lot of people use JavaScript libraries, and perhaps they could also be able to provide the libraries through IPFS, and we will see how and why this is important. Okay, so let's. I mean, this is a very quick introduction to IPFS, and just 2 days ago, they also announced a handsome plugin for Firefox and Chrome in order to make IPFS more friendly. So IPFS is an enabling technology. The parent company who wrote the first version of the software is Protocol Lab, and is trying to use this IPFS technology to build a blockchain-based distributed file system named Filecoin. So it's a more enabling technology than an end-user technology. Okay, but I think that this add-on, it's very interesting. You can try it out. But there is another technology I told you about, this DAT project. How many of you knows about DAT? Nobody. Oh, that's a shame. So DAT is a more end-user technology. It's also an enabling technology. It was thought and developed initially for the scientific community in order to share and distribute large data sets of data. So it has very interesting features like synchronizations between nodes, and also supports a more dynamic way of doing things. So you can change we saw with IPFS that if you change something inside the file, the hashes changes with, oh my God, 10 minutes, so we have to go faster. With that, instead, you can continuously update your files, and it gently points you to a new version of the file with the same hash. Okay, so it supports versioning and other things as well. So it's very easy to install that. It's a JavaScript library. The main difference is that you create a DAT folder inside the folder you want to share. So you don't start a single daemon on your machine like IPFS, and you don't have a single repository like IPFS does. You have many daemons, many folders from which you can share your projects. Okay, and just to give you an idea, very quick idea, I tried to bring to that my blog. I have a blog on DigitalOcean virtual machine based on Ghost blogging platform, so it's dynamic. I converted my blog to a static version with Jekyll, and I tried to share it with that. Okay? So let's do it here. And also IPFS. I have to say that the experience with that is much more easier from an end user point of view. So I already created the repository inside this folder with that create. So if I say that share, I start the command line daemon on top of it. Okay. Okay. And we can actually, when you start the daemon, you can start the daemon in two ways. The first way is to enable also an HTTP gateway. So you can see your, just a second, it needs to start to warm up, hopefully. Just a second. No. What's going wrong? I don't know. We will see. In any case, this is the hash of the whole website. Okay. I can show you another interesting thing in the meanwhile, while it's warm up. So actually, there is another important feature with that in order to make it simpler, which is a browser called Beaker. Sorry. This is not the best. Okay. So there is also a UI for that. That was what I started. So the Beaker browser is a browser that supports actual access to a DAT, peer-to-peer system. As you can see, and in this way we avoid completely the problem with HTTP gateways. So using Beaker, you can access a site with links, okay? Sorry. Okay. And you're accessing it through a pure and secure peer-to-peer network, okay? And at the moment, we have 3 peers connected, okay? So this is very interesting technology. I mean, the Beaker browser is based on Chromium. You can start use it from today and try to experiment a bit, and provides you information about what is happening. Because another important thing with that is that you can clone or sync or fork a site. So I have this site with many images, with many files, links, and so on. It's a static site. I say .create, .share, and at this point, I have an hash, and everybody on the internet can take the hash, access the site, and clone it. And also sync it. And there is also an interesting feature which is called, I don't have the time to show you, but it's live reloading. So if I change something in my original site, I post a new post, and the Beaker browser is set to do active reloading, the browser reloads the latest version of the site with the new article published inside it. Okay? I have to move fast, sorry. Okay, this is Beaker. And I invite you also to take a look at the DAT installer, which is a very interesting application in order to distribute mobile apps in a distributed way without a single store. So actually, you can distribute mobile apps through mobile phones. So you have the app installed on one mobile phone, and you can use another mobile phone, reach for the hash through that, and download the application you want. And why we need such technologies? Because of this. I don't know if any of you remember the problem with LeftPad. LeftPad. One very clever developer who maintained 250 npm repositories at some point decided to unpublish them all because of legal issue he had with one of them. And so everything broke. Okay? So if the same library, which is open source, which is public, which should be accessible by everyone, was stored inside IPFS or DAT, no matter if someone decides to unpublish it, it will be available every time, everywhere. And also for developing countries, this is very interesting technology because you can access the internet and take your laptop to a disconnected network and enable the disconnected network to download everything, again, without changing the address, but at worst, changing the gateway. Okay, everything continues to function. And for example, when the Turkey government shut down the Wikipedia version of the country, it was ported to IPFS in order to enable other people to access it again. Okay? So, very quickly, these are the advantages. The bandwidth is upon the client, not the server. The peer-to-peer is self-organizing, no matter the topology, no matter, you don't have to care. Okay? And the content is resilient to a lot of attacks, also censorship. Okay? And we need to go faster with Ethereum. I don't want to explain you anything about Ethereum, except that we can use Ethereum to build Ethereum or another platform like Ethereum to fill the gap, to build a completely decentralized and distributed computing platform outside Amazon. This is not production-ready technology. And when you try to download the Ethereum client, this is the web page that the Ethereum Foundation shows you. So this is not about something that can substitute tomorrow AWS, but it's something that we should work upon in order to enable more people to access computing platforms and powers. And yes, there is a framework. For example, Embark. We can have a quick demo. How many minutes do we have still? 5? No, nothing. Okay. Unfortunately, 3 days ago, IPFS published a new version of IPFS that broke EmbarkJS, so you have to install a compatible version. But it's very easy. You can install the Ethereum client with npm install EmbarkJS, and you can quickly go through the demo that enables you from JavaScript on the client to store and read things on IPFS and execute smart contracts on Ethereum and start thinking about how to develop your next web application in a more decentralized and distributed way. So, again, you don't have to manage servers or services. This is the Ethereum part of the problem. And the trust is not upon the provider. The trust is upon the network. It's very hard to shut down completely a peer-to-peer network. It's much more easy, for example, for China, to say to Amazon, like it has done, please, this kind of services should not be available in China. And Amazon enables you to use their services, but in a slightly different way, with firewalls and censorship in between. And resilience and scalability is guaranteed by the distributed networks as well. And of course, I invite you also to read and subscribe to our technology radar. The volume for the 2018 is almost ready, so this is the past year, and we are hiring in Italy, so if you are interested to work with us, please join. Okay. Is there any time for questions? Okay. So we have hopefully a few minutes for questions if you have any. Please, just a second. Just a second. Okay.
Yes. What about the privacy regulation and where the stored data? What about the privacy regulation about the local privacy regulation like GDPR and where the data are stored?
Okay, of course, there are two kinds of answers to this question. The first answer is the answer that DAT gives you. So for example, DAT enables you to share encrypted data natively. So you decide who is available to open the data, not to share it. So you can share publicly, but access privately. Okay? So that's the first question. And the second question, of course, in a peer-to-peer network, you have to ensure that you store encrypted data also in IPFS. Otherwise, it will be available for everybody. Any other question? Okay. Thank you all. Bye.